All right, let's set the scene. It's 2 a.m. You've got that huge Java assignment due in just a few hours, and you've completely hit a wall. The code just will not compile, that deadline is getting closer and closer, and the panic is definitely starting to set in. So what do?
You know the feeling. The cursor just blinks at you. The compiler is screaming errors that might as well be in another language. All those concepts that seem just a little fuzzy in the lecture, yeah, they're totally abstract now. That urge to just Google for a solution, to just make the problem disappear, it's overwhelming. If you've ever taken a computer science course, you are probably nodding your head right now.
And that temptation can lead you down a path that seems like it solves everything, just outsourcing the work. But I'm telling you, it's a trap. It feels like a quick fix, but it doesn't actually solve the real problem, which is the fact that you're stuck, and you need to learn how to get yourself unstuck.
I mean, just look at this trade-off. It's brutal. In the short term, yeah, you get relief. The assignment's in, you get a grade, crisis averted. But the long-term pain is so much worse. The next assignment, it builds on this one. Then the final exam comes around, or even worse, a technical interview for a job, and you suddenly realize you've learned absolutely nothing. You've basically paid money to become unemployable.
And let's just be real for a second. On a practical level, your professors know. They have tools that sniff out plagiarism like a bloodhound, and they can absolutely spot when your elegant, perfectly commented code for one assignment suddenly turns into a messy, confused mess on the midterm. The risk here isn't just getting a 0. It's getting an academic violation on your permanent record. Not worth it.
Okay, so let's reframe this whole thing. The problem isn't that you're bad at Java. No way. The problem is that you're stuck on one of a handful of very common and totally solvable concepts. You don't need someone to do the entire assignment for you. You just need to break through one specific blocker.
So, seriously, take a second and think about it. What is actually stopping you? Is it the whole project from start to finish? I doubt it. Or is it one of these classic, headache-inducing topics that trips up pretty much every single student who's ever learned this stuff?
Yep, here are the usual suspects. You've got recursion, where a function just seems to magically call itself into oblivion. You've got those super abstract, object-oriented ideas like inheritance and polymorphism that feel like they're from another planet. And of course, good old Java with its unforgiving syntax and error messages that are just so cryptic. Do you see your problem on this list? Good, because naming it is the first step to beating it.
So for recursion, that's the big one, right? Here's my advice. Stop trying to trace every single function call in your head. You will literally break your brain. Instead, just ask these 3 questions. Now, the most important one here is step 3. You don't have to understand how, say, factorial of 4 works. You just have to trust that it does. If you can take that leap of faith, then writing the code for factorial of 5 becomes super simple.
Decoding Java's compiler errors is a skill all on its own. The messages feel so personal, like the computer is mad at you, but they're really just patterns. Cannot find symbol almost always means you've got a typo somewhere. A StackOverflowError? That's a huge clue that your recursion never stops. And here's a pro tip for you. Always check the line number the error points to, but also check the line right above it. That's often where the real mistake is hiding.
Okay, so instead of outsourcing the thinking, let's talk about the real strategy here. The goal isn't to become a Java master by sunrise. Nope. The goal is to learn just enough to solve the one specific problem that has you stuck right now. That's it.
This whole approach boils down to a really simple 4-step workflow. First, get super specific. Don't say, I don't get objects. Say, I don't know how to write a compare to method. Second, find one clean example of that single concept. Third, and this part is absolutely critical, type it out yourself. No copy pasting. You have to build that muscle memory. And finally, test it with your own simple data to prove to yourself that you actually get it.
This all brings us to a really important distinction. Getting help is good. You should get help, but there's a line. Good help is asking a TA why your recursion isn't working. Bad help is asking them to write it for you. The question you should always ask yourself is this: am I using this resource to learn, or am I just using it to avoid thinking? Now, let's zoom out for a minute. Because these assignments, these late nights, they aren't actually about making you a perfect Java coder. They're about something much bigger than that.
Here it is. This might be the most important thing to understand. That feeling of frustration when you're debugging, that's not a sign that you're failing. That feeling is the feeling of learning. It is your brain literally building new pathways it needs to think like a programmer. The struggle isn't some obstacle in your way. The struggle is the entire point.
Because when you finally push through that wall,
You're not just learning the syntax for a for loop or the textbook definition of polymorphism. You're learning something way more valuable. You are learning how to learn. You are learning how to get yourself unstuck, and that is the single most important skill a software developer has, period. Your entire future job will just be a series of new languages, new problems, and weird bugs you've never seen before. The skill you're building right now, at 2 a.m. with a coffee, that's the one that will actually define your career.
So, at the end of the day, just remember this. It is always, always better to struggle through and submit your own imperfect, maybe B- code, than to turn in a perfect solution that you didn't write. The real learning happens in the struggle, not in the final submission.
So as we wrap up here, I want to leave you with this question to chew on. What was that one concept for you? Was it recursion? Generics? For me, it was really understanding hash code and equals. Just recognizing that we all hit these walls is the very first step to figuring out how to climb over them.